Good evening to all the distinguished participants, researchers, scholars, and the member of JK Economic Association. It is my pleasure to welcome you all to day two of an international workshop on frontiers in structural equationing modeling. Focus on one of the most critical pillars of SEM research, measurement model and validity. Today, we are privileged to have with us eminent academician, researcher, Dr. Priyanka Yadav as a resource person. Dr. Yadav is currently serving as an associate professor at National Forensic Science University, Gujarat. She holds a doctorate from the Department of Management Study, IIT Roorkee, one of the India's premier institute. Her academic and research expertise lies in finance and accounting with strong focus on microfinance, rural finance, sustainability, and financial inclusion. Her work in these domains had contributed significantly and understanding the financial support in vulnerable community in inclusion and growth. Her research has been widely acknowledged for analytical depth, policies, relevance, and methodology in rigorous research work. Today's session, we are privileged to have a very strong resource person with a strong research background. So, on behalf of JK Economic Association, I extend a warm welcome to you, Dr. Yadav ma'am, and looking forward to have an expert learning as well as researching on about the important topic that is contributing a new era of research. We once again welcome you. And now let's begin the session without wasting any time to hear from Dr. Yadav.
So thank you so much for the introduction, ma'am. So as Madam told, Dr. Priyanka Yadav, currently working with the National Forensic Sciences University, Gandhinagar. So it's a university which has been established especially for forensic sciences. And in this university, one of the management is management department, where currently we are offering BBMB integrated program, UG, it's a UG program. Further, in addition to that, we are also offering PG programs in various domains like healthcare and hospital management, further BAI, business analytics and intelligence, financial management, and our core area, that is forensic accounting and fraud investigation. So that is a brief introduction of mine. So let us start today's session. So the topic that I have been assigned is SEM, measurement model validity. Okay, so let us start this interactive session. So in case if you have any questions, doubts, you can of course ask me when I wind up this. So just give me a moment. Okay, before moving into how we perform this SCM model in MOS or PLS, smart PLS, I would like to do with the basics of this model, okay? Because without that, we will not be able to understand the full picture. So I think some of the basics of this model, that why at all it is used and in what cases do we employ this model, has been already discussed in the previous classes and previous lectures. So I start my share. And first of all, let us first try to understand what exactly SEM is in order to create the base at least. So as all of you must be aware and must have heard of this term called SEM. So SEM is like building up a map of relationships between some ideas that cannot be directly measured. So we have to measure it indirectly. you must have seen some cases in economics. There comes a concept of utility, for example. There you must have seen that we cannot sometimes measure it directly, because direct measurement of utility, since it's a qualitative variable, it will not be feasible to measure it. Rather, we try to derive it indirectly. So similarly here also, we try to direct some relationships that cannot be directly measured. So that is where this SCM comes into picture. Okay. So further it says, give you an example of where to use this model. So for example, an example states that suppose there is some service quality which affects customer satisfaction. Okay? So the customer satisfaction is affected by this service quality. What kind of service we are offering, customer satisfaction is going to be based on it, and which in turn is going to affect our loyalty, that how much customer is going to be loyal with us, and in future whether he will buy some repetitively buy our product or not. Okay? So since there happens to be an indirect relationship, you can see that because service quality will first impact his satisfaction, and in turn this satisfaction will impact this loyalty. Okay, so here it is a clear cut case of indirect measurement. That is, your loyalty is going to be based on this quality, but first we will have to measure the set quality, and there's its impact on satisfaction, and finally we are going to measure loyalty. Okay, so it says that there is something called construct and there is something called variable. Okay, I think all of you must have done this factor analysis, which is basic of understanding this SCM model, because without understanding the basic we cannot proceed with SCM. Okay, so I hope all of you are aware of these basic terms called, what is a variable, what is normality of data, what are outliers, further what is validity, what is reliability. So I hope you all, if not fully aware, then at least you must have heard these terms in somewhere in your during your research. So the understanding of these concepts is the bare minimum that is required out of you. Then only you will be able to understand how to measure this constructs, or how to reliability and validity. Okay, so it is further taking you into an example onto this SEM model, and it says that, for example, if your construct is customer satisfaction, and the items that measure it are the following, and there are three items that measure it. So customer satisfaction has to be measured, and we have three variables we can see that are going to measure. Okay, so the first one is that, suppose if you have a question like whether the customer is happy with the service or not. So in case we ask him the question that whether he is happy or not, and he says that I am happy with the service, and he rates it on a scale of 5, he rates it 5. Okay, similarly, another question that is asked in order to measure this customer satisfaction is whether the service, a particular service, met his expectations or not. And in similar lines, we have asked him a question that whether he will continue to use the product or not. And in case if he rates this 5, so it means he is going to continue the use of this particular product. Okay, so here we can see that we have measured this satisfaction indirectly with the help of these three questions. Okay, so SCM will help you to check two things. Because before proceeding further into more complex terms, that whether a particular variable is going to affect our overall model, it is going it is going to create some kind of modality, whether it is going to have direct or indirect impact on our overall construct. Before that, we have to go into the basics, that whether the questions that we are going to ask are actually going to measure what we intend to ask. So our primary motive is that. So before proceeding with SCM, we have to make two checks. Okay, so these are initial checks. Okay, so first one is of course measurement model, and under this we ask this question, that we ask actually ourselves, that are the questions that we are going to ask are actually measuring what we are supposed to measure. Okay, so that is the first thing. And another one is the structural model. And in structural model, we try to find out whether the relationships between constructs hold. Okay, so a particular construct, suppose we are going to measure some kind of whether a person is willing to buy a particular service or not, or a product or not. So there can be several variables or questions that through which we can try to understand whether he is going to buy or not. Okay, so before that we have to ask that do the relationships between the construct will hold or no, that is the service quality leads to satisfaction in our case, in our example, and ultimately will the satisfaction lead to your loyalty, or we are just running after redundant things which are not at all related, and we are trying to create a relationship between them. So that should not happen. So that is why the first and foremost thing that you have to do is, before entering a cinema hall, you just have to ask the question whether you are buying a valid ticket for the show or no. So that is what measurement model is about. And in measurement model you are trying to question yourself that whether we are, whatever we are going to measure, are our questions measuring that. So that is the first thing in measurement model that we have to do. Now, another thing is that in today's session, since it's a long thing, SEM is not a thing that you can an easy to go thing that you can understand within a span of 1 hour or 2 hour. You have to spend a significant time on understanding this. So my part of discussion will be focused on measurement model. Okay, so how to do this initial screening basically, that I am going to make you understand, trying to make you understand. Okay, so we talk about it, and it says that measurement model will basically check three things. First one is, are the survey items reliable? So that is, we are going to perform a reliability test. Second is, do they measure the right thing that we intend to measure? And third one is, are the constructs valid? Okay, so these are the three questions that we are going to answer through this measurement model. And in case in our if our model fails to do all these things, okay, reliability fail is there, validity fail is there, then we will not continue further with our model. Okay, we will have to make modification to our data, we will have to make changes to our variables and ultimately the construct. So we will have to change everything, and then only we can proceed further. So further it talks about structural model. And in structural model, of course, as I told you, that that is a next level thing, that once you pass your initial screening, then only you will be able to enter into the second mode of structural modeling, where you will be deciding that what kind of relationship is there, a causal relationship between two variables, is variable A leading to variable B, or B leading to C, or are they somehow interrelated, and how their consistent, their dependence on each other is decided. That you are going to decide in this structural model part, and that is not for sure not going to be covered today, that you will be covering in your subsequent classes of this 7 days workshop. So let us continue with what we are concerned today. Okay, why we have gathered today here. So we talk about our measurement model. So it says that because if your questions are bad or are not trying to depict what you tried them for, you framed some questions, and if they are not able to cover what you intended to ask your respondents, then of course your whole exercise will go fail, and further your hypothesis will go wrong. You are not able to set your correct hypothesis, alternate hypothesis, null hypothesis, nothing. You are not going to frame the right hypothesis, then how you are going to test them? So the results will be, of course, invalid. It will lead to spurious things which have no meaning in real life. So that's why this measurement model's validity holds relevance. It further says that imagine, suppose you are trying to test with a model that has no validity or reliability. Then it is similar to checking a person's temperature with the help of a broken thermometer, which is not and never going to depict the correct reading. So what at all is the need to do when we know that we have a broken thermometer and the readings are not going to be right, and whatever we are going to measure is not going to be true? And what at all is the need to measure it? So that's why it is important. So with the help of this measurement model, what we are going to do today, okay, so there are basically 5 things that we have to test with the help of a measurement model. Okay, so the first and foremost thing that we have to test is the normality of data. Okay, So by normality of data, we mean to say that with the help of our observations, whatever respondent data we have collected, suppose I have, for a survey, I have collected a data of 500 respondents, where I asked all those 500 respondents to rate my services, that how do I teach. Okay, suppose 500 students were there, and I asked them that okay, you tell me how much satisfied you are with the level of understanding that I am offering you through my teachings. Okay, and majority of my students are rating me between 3 to 5. Okay, so that's okay. But suppose majority of my students are going to rate me on the extremes, that is 1 and 5, and that can be a problem. Similarly, this was a qualitative data, and similarly this can happen in the case of quantitative data. That suppose I'm going to ask my respondents that what is your monthly income. Okay, and suppose once again our respondents happen to be 500, and for those 500 people, a majority of the people, or of the respondents, had an income which averaged around 1 lakh, and it was in fact between 90,000 to 1 lakh 20,000 per month. But there were 5 or 6 respondents whose income happened to be rupees 10 lakh. Okay, so that will set out to be an outlier, and that will disturb my whole data, because the mean will be disturbed, because and the median will be disturbed, and so on, and my distribution curve will also be disturbed with that. So in case if I have such kind of data which is giving me a misleading picture of the overall population, I will have to act, and that act has to be in the form of removal of that entry from my data, because I do not want to conclude my results with outliers. I want a normal population, a bell shaped curve I want. So that is why the data has to be normal. The first and foremost thing that we have to look before running an SCM is the normality of data. Okay, now another thing that we are going to test, or another barrier to entry to this SCM model framework, is reliability, that a model has to be reliable. The third thing is the validity of the model. The fourth one is multicollinearity, and fifth one is common method bias. So all these 5 tests or checks have to be put in before you enter into the world of this SEM. Okay, so now let us discuss these with the help of some random examples and some basic examples that we will be able to easily understand and relate to. And further, we, after understanding these, I will give you a sneak peek into how they are run in the MOS. Okay, so that we will do, but first of all let us try to understand the basic, because that is my way of teaching, that before proceeding with the basics, I cannot proceed with advanced, and I hope a majority of you will agree to it, that first basics have to be learned. So first of all, we talk about the first thing, and this is normality. As I told you, that if you plot your data, do you get a nice bell shaped curve or not? Okay, so bell shaped is like it's a shape in the shape of bell. Okay, with 2 extremes, one on the left and one on the right. So your curve that you plot with the help of your observed data, that has to be bell shaped. If it is not, then you have to act on time. You have to remove the outliers. You can convert your data into, if in case if it was quantitative data and you have put in the numbers as it is, then you have to make maybe some interval classes, so that it can get into some class, and you get some symmetric data. So symmetry has to be there. That way you will have to act, but you have to do something in case if you are not getting this bell shaped curve. So with the help of an example, it has been taught here that suppose you asked 100 customers whether they are satisfied with a particular service or product. So, and they answer you on a scale of 1 to 5, where 1 means they strongly disagree to your statement. Okay, and 5 means they strongly agree to your statement. So this was the response from 100 customers, and if most of the responses are 3, 4, 5, okay, so this can be termed as normal. But if the response is 1 to 5, because these are the extreme ones. Okay, 1 is another first extreme, and 5 is another extreme. So that is not normal, because your values are lying in the extremes. You're not going to get a bell shaped curve. So that's why your data is not normal. Okay, So that's why it has to be tested, and if it is not there, you cannot proceed with the SCM, at least not with the PLS. Okay, so it further says that why at all normality matters. Okay, so it says that because covariance based SCM will require normal data. However, in case of PLS, we as researchers do not care much about it. However, it has to be cared. If researchers argue that if the condition of normality is not met with, then you cannot proceed. But in a an environment where we are living today, every kind of research is published, and when I have seen papers getting published when the data was not normal, and the authors arguing that that this can happen because it is a real time depiction of the reality. However, some researchers do not really agree to it. That what is the point in using a skewed data? You suppose you go to a judge and you already know that this person is biased against me. So why at all he will go to him? So similarly here also, there is a debate over it, that whether to use it or not. But PLS SCM does not care much about it. And in case of abnormal data also, or not so normal data, PLS can be run. Again, this is in contradiction with the OLS regression assumptions. Further, we talk about another important entry barrier that I talked with you, and that is internal consistency. Okay, so basically, we want to know whether our questions are consistent or not. So you want to know whether if the items measuring the same constraint are consistent with each other. You suppose you are measuring something. Okay, are they contradicting each other? Suppose I want to measure satisfaction with the help of 5 questions. So they must not be contradictory with each other. Rather, they must be in alignment with each other. So suppose if someone is agreeing to our first question, the second question he must agree to. There must not be any inconsistency. Okay, similarly, if we have a valid construct that has been pre tested with the help of some pilot testing, then it must proceed with third also. That if first a person is agreeing with our first question, then he must also agree with the third also. Then we can say that our research is reliable, and we need not replace our questions. We need not rework on our questionnaire. Okay, so that it is about. So with the help of an example, further it has been made understood that suppose we are going to measure customer satisfaction for a particular product, and there are three items. This customer satisfaction here happens to be a construct, and this construct has been measured with the help of three variables here. Okay, and the three variables are, first one is that I am happy. Okay, someone is telling that. Now further he is telling that I am satisfied, and further he is saying that it met my expectations. So as you can see here, that all the three are somehow related. Why? Because suppose I am happy today. Okay, so it means I'm feeling satisfied also. If I am happy with the use of some product, it means I am satisfied with the consumption. Further, since I am satisfied with the consumption, so it means that whatever my expectations were met. Okay, so we talk about something called consumer surplus, that whatever I was willing to pay for the product, I have paid that. Okay, and in fact there can be surplus also, that whatever I was thinking the price of that product to be, that was too low as compared to the actual price. So I will be feeling happy that okay, this was the price I was thinking that I should pay, and this is the price that I have paid. So I am overall happy that I had to pay 2000 in my mind, that okay, this for this particular gadget will cost me 2000, but I came to know that it is going to cost me 1500. Wow, I'm too happy. Okay, so it has met my expectations. So all these three statements, you can see, so they are somehow related to each other. So if a person is saying that I'm happy, he must also say that I'm satisfied, and he must also say that I'm my expectations are met. So that way we can say that okay, the items that we are going to measure are reliable, are consistent actually. So if the same has been explained here, and it says that this reliability can be measured with the help of something called Cronbach's alpha. Okay, so since we are not doctors, by looking at the faces, we cannot simply say that how this whether a particular questionnaire or the questions asked in the questionnaire are reliable or not. So for that, an instant solution for us is there, and that is Cronbach's alpha. So and I hope all of you must have, through your research journeys, you must have heard this term called Cronbach's alpha, which is a very common term, be it quantitative research, be it qualitative research, any kind of research. We generally use this term to check the reliability of our scale. And it says that if Cronbach's alpha's value is greater than 0.70, then it's good. And if it is lesser, then it is, we call it less consistent. And we have to again reframe our questionnaire and do the prior layer testing before actually going for the real test. It further says that these two are checks to measure something called internal consistency reliability, which simply means that do all the questions that measure the same construct hang together well. Further, with the help of one more example, it has been told here that if Cronbach's alpha value is higher than 0.70, then it's good, and if it is between 0.80 to 0.90, it is very good. And if it is higher, so it means you are using duplicates actually. If it is too high now, so then also it is not good. So it has to be between, generally if we talk about me, that what kind of Cronbach alpha value do we accept as researchers? We means me and my common friends group who are researchers. So we generally accept it, 0.70 to 0.73, and not more than this and not less than this, because a very high value means you are asking the similar question. Okay? So that also means you are using variables which are measuring the same thing. So multicollinearity. So why at all to use that variable? That will give you a very high R square, but redundant variables which are not of no use. So why to use those two variables? Instead, use one variable. So that is how we interpreted this. And another one it is talking about is composite reliability. So first one that you have to do to test this reliability is of course Cronbach's alpha, and another one is composite reliability. So it says that this is a more accurate and SCM friendly reliability measure. How well do the items reflect the construct based on their factor loading? So factor loadings you must have heard during your factor analysis, you must have conducted in case if you are a researcher who works on qualitative data, then there you must have seen these terms: factor loading, CFA. So from there it has been taken. So it says that unlike Cronbach's alpha, it uses actual item loadings and does not assume equal weighting, and is better for SEM. For both type of SEM it is. So it is for PLS also and CB based also. It is considered as a better measure. And if we go to the interpretation part, that how to interpret similar to Cronbach alpha, that what is the acceptable level, what is the goodness of fit. So it says that if CR is greater than 0.70, then it has to be accepted. If it is greater than 0.80, then it is considered good. And if it is greater than 0.90, then it is excellent. But more than 0.90 is again suspicious, because it is too high, and it is an indication that we have used some variables which are replica of each other, which were actually too much correlated with each other, that they are capturing the whole of R square. Okay, and they are not giving other variables the space to adjust. So using such kind of variables in our regression can make our actually meaningful variables redundant. So that can be an issue. So that's why too, we have heard that excess of everything is bad. So that is this excess, that not beyond 0.90. And in case of practicality, if we talk about it, so the maximum researchers use value between 0.85 to 0.90, and that is considered good in our academic research. Now we come to another thing, that is the third entry point that we have to check for, and that is convergent validity. That is, do items for the same construct agree or no? Okay, so construct is, again, once again I tell you that construct is a big thing. Okay, that we are going to measure some kind of satisfaction out of use of a product, then that can be influenced by so many things. Okay, similarly, suppose if I talk about whether a person is willing to take a particular financial service or not, then that can be affected by so many factors, whether his peer group is buying that or not, similarly whether he has this pocket money or not, what was his past experience, what expectations does he have. So there can be so many factors. So construct is a big thing, and this construct is measured with the help of several statements or questions or variables. Okay, so it further talks about the third point, and that is convergent validity. So, do items for the same construct agree or not? So, with the help of an example, it has been told that you expect that the three satisfaction items measure the same idea. So, each item should be strongly related to the construct. Okay, suppose I am going to measure that whether he is satisfied or not. So, all my three questions, I am asking my respondents three questions. Okay, I'm getting my primary data collected. Okay, and from the respondents I have to ask the questions which ultimately lead to customer satisfaction. They should not be redundant, and they must lead me to my construct. Okay, they should be strongly related to the construct, so that then only that our the questionnaire is valid. Otherwise it is not valid, and we must not proceed with our SCM. Okay, so further it says that suppose our construct happens to be customer satisfaction, and for this construct we are going to measure it with the help of three items. Now the first item happens to be that the customer says that I am satisfied with the service, and another one is the service met my expectations, and third one is I am happy with the service. So three statements are there. So it says that these items should converge or come together to measure satisfaction. If they do not, the construct is weak or unclear. Okay, so it means convergence means, suppose in simple terms, if you want to understand this convergence, suppose I rank some variables. You must have heard of this ranking, that we are ranking someone from a scale of 1 to 10. Okay, and another person is also ranking, then there must be convergence. That is, they must go in the same direction. Okay, suppose similarly in case of if we are measuring some development of some states, in case of quantitative data also, and we are going to rank them, that what is the monetary income of people there, okay, over the years. So we rank those data for suppose 10 years. For 2001 we did the survey, for 2002 and 2003, and through 2009 we did it. Okay, so by convergence, what I do mean is that the ranking must go in a similar direction. Okay, at some time there must be uniformity in the answers provided. Then only I will be very very proudly saying that okay, I'm measuring the construct with the help of these variables, and they are going in the same direction. I must not ask any redundant question at this point that is not leading to my overall construct, that is not anyhow related to my construct. So that is what has to be tested, and in case if it is not converging, it is not leading me to my construct, then I must not go ahead with that question. So an example to this has been given here, and it says that a factor loading tells you how strongly each item connects to the construct, and loading is like a correlation between an item and the construct. Of course you must have seen that how an item is related to the construct. Okay, and here some loadings are there. Okay, so one item number one is there where satisfaction has been measured, and the loading that has come to this particular variable is 0.82. For similarly, and we are going to again measure our customer satisfaction, and with the help of second question we came to know that our loading came out to be 0.88, and similarly it comes out to be suppose 0.75 in case of our third variable. So it means that people who score high on the construct also score high on these variables. So that is the most important thing, because ultimately construct is what the average of all these na. So that is why every question, every statement of ours or every variable of ours must lead us to the overall loading which is high, and it must lead us to our overall scale, that is it must be too high, that it converges, okay, with our main motive. So that is the thing. And further it has given you an ideal interpretation, that suppose the construct was this customer satisfaction. Okay, this was our construct, and this construct, since we could not measure it directly because it is quantitative in nature, and it was influenced by so many statements or we can see variables. So at that time we tried to measure it indirectly, and with the help of these three questions or variables we tried to measure it. So all these questions must have a loading which is greater than 0.70. Okay, so if it is higher, so we can keep them, or up to 0.60 we generally accept it. But if it is weak, then it means that we have used a redundant factor, and this factor is not at all contributing to our construct. So we must immediately remove that particular trait or that particular factor, and must use some other factor in an order to measure our construct. Okay, so that is about it. And the fourth thing that has been put as an entry barrier before entering the SEM world is discriminant validity. That is whether our different constructs truly different. Okay, we have used several constructs, so they are different, or we are trying to measure the same thing with the help of different questions. It is like, there are two children, and they are looking, when we are looking at them, they are of the same face. But if they are of the same face, then why at all to try to find the differences between the two? We can find the differences only if some of the personality traits are different. If two are going to be same, then why to measure that with the help of two? Why to waste our time? We can proceed with one also. So these constructs must be different and unique from each other. So the main motive here is to identify the uniqueness of construct, and if you find them not to be unique, then you must not proceed with two. Okay, then you should proceed with one. Now, with the help of an example, it has been made clear that before applying this your data with the SEM, you must measure this discriminant validity. Okay, so whether the groups to which they belong are different or not, that is another question that we can address with the help of this discriminant validity. And it says that suppose you have two constructs. One is service quality and another one is customer satisfaction. Okay, and we want to ensure that construct A is not same as construct B. Okay, because as I told you that if they are going to be same, then we should not go ahead with two. Rather, we should measure them under one head. Maybe we are going to say it as customer satisfaction, we can name it as service quality. But if they are measuring the same attributes, then there is no point in measuring. And it further says that if you want to ensure that they are not accidentally measuring the same thing, that of course we must go ahead with discriminant validity, that they have the power to discriminate between the groups to which they belong. Okay, suppose I say that, suppose if a particular individual is there, who is investing in mutual funds, and there is another individual who is not investing in mutual fund, then my respondents are two different people, and I want to find out that what exactly are the factors which lead them to this decision of investing in mutual fund. Then maybe I'm going to classify them into groups of two. Okay, one is a non-investor of mutual fund, and another one happens to be an investor of mutual fund, and I discriminate between them with the help of certain factors. Suppose age is there. Okay, then there is educational level is there, then the caste to which they belong, or maybe the experience that they have been exposed to, or maybe their income. Okay, so these factors whichever I am using, they must be, if I am using them, then they must be actively the able to discriminate between these two groups, these two people. Okay, if not, then what at all is the point? So that is the thing. Now it further says that this is like checking if two siblings have different personalities or not. Okay, so the test that we apply here in an order to check whether our constructs are truly different or not, that is, two types of tests are generally done. Okay, there can be more tests, but generally in case of SCM we perform these two tests. Okay, so first it is talking about HTMT test, and it says that to further understand these two constructs, we try to help understand this with the help of an example. Suppose two traits are there, service quality is there, and customer satisfaction is there. So these are the constructs that we are going to measure. Okay, and as I told you that they should be related to each other, but should not be identical. That is the point. Okay, related because without relation, so we cannot create the model, and but not identical. That if this goes up, then this also goes up. If this goes down, this also goes down. Then what at all is the point? So they should be related. Relation must be there. Either one way, two way, it can be there, but it should not be identical. Now, it further says that if your items for service quality are too similar to your items for satisfaction, then you have not measured two constructs, rather you have measured one construct twice. So that is the thing. That is why, as I told you, that it is important to test the discriminant validity of your model, because if they are measuring the one and the same thing, then what at all is the need for two constructs? So that is a failure of the discriminant validity. So they must be able to belong to two different groups, and that is when you are able to discriminate between them. Now, another one is it is talking about our first test, that is Fornell Larkel model. So it says that this method compares the square root of AV of a construct with its correlation with other construct, and the general rule of thumb is that the square root of AV should be greater than the correlation with any other construct. Okay, so it also means that the construct will share more variance with its own term than it share with another construct. So with the help of an example, it has been further stated that suppose you have three constructs, that is satisfaction is there, service quality is there, and loyalty is there. And suppose your AV values happen to be 0.64. For second, it happens service quality, it happens to be 0.58, and for loyalty it happens to be 0.70. Then after squaring the root and interpreting the intercorrelation between two, because correlation सिर्फ variables के बीच में construct के साथ में we have to do two things. कि the first thing that we have to do is whether a variable is correlated to the construct, पहली बात. Now second one is whether they are interrelated, some kind of correlation exists between the variables or not. Okay, so that has to be tested. Now the rule of thumb for evaluation of this Fornell Larker criteria is that you have to look at those two things. Okay, take square root of the AV for the variables, and further you have to look into the interconstruct correlation between the variable. Okay, and the rule is that if combinedly this intercorrelation between the variables happen to be lesser than 0.80, then our discriminant validity is achieved. Otherwise, it is not achieved. Okay, so that is the rule of thumb. Now, further, it talks more into HTMT. So that is another way of looking into this discriminant validity of our, of our model, that we are able to discriminate between two categories or not. So the first one that I have told you is Fornell Wala test, and the second one is HTMT test, which is another type of testing. You must have seen in SPSS, if we perform some kind of maybe normality test, multicolority, and so on. There are several type of tests, with one having advantage over the other. So these are the two tests generally that there can be other tests also, but generally we prefer this Wala test, that is Fornell Wala test, more as compared to this HTMT test. So what exactly it does is depicted here. So it says that HTMT is the ratio of correlation between items of different construct versus between items of the same construct. Okay, so basically HTMT checks how similar two constructs are, and in case if they are too similar, discriminant validity fails. So the decision rule, the rule of thumb is that if HTMT value, this will be given in your PLS software, so you just need not do anything, you need not calculate it. This is the basic of how actually they are calculated and why at all they are calculated. So that is what I'm trying to make you understand. It says that the decision rule is that HTMT value, if it is less than 0.85, then it is strict. Then if it is less than 0.90, then it is acceptable, and if it is greater than 0.90, then constructs are likely the same. So there is no point of discriminating between the two, and that is where our discriminant analysis fail and our validity fails. Okay, so greater than 0.90 value cannot be accepted in case if we are going to test the validity. Okay, now, further, it has given you one more example where suppose two items of satisfaction and service quality have correlation around 0.75. So, two variables are there, two constructs are there, जिसमें दोनों का correlation was 0.75. And the items within satisfaction correlate around 0.85. So, the items with the help of which this particular satisfaction was measured. Okay, suppose in an order to measure satisfaction, we ask two questions. and the correlation between those two questions happens to be 0.85. Okay, similarly there is another question that is asked, and that is service quality. And in order to measure this construct of service quality, we have again taken two questions. Okay, and the correlation between those questions happen to be 0.80. Okay, so how do we measure this HTMT? So this, with the help of this formula, I have shown you that how to measure this HTMT. And since it is below 0.90, it is acceptable. Had it been above 0.90, then it would have meant that the constructs are really the same thing, and there is no need of taking both the question. Rather, we can proceed with one question only. So that is it. Further, it is explaining, had it been higher, then what would have happened. So it says that which one is the best one. So I hope you must have read this Hair Valley book. It is the most common book that we as SMS research, SEM researchers go through, and this is the most uh, I think famous book. And this book recommends HTMT. Okay. Further, we talk about the fifth entry barrier that we have to, go through before entering into the SEM world, and that is multicollinearity has to be tested. Okay, multicollinearity means the variables that have been used to measure a particular construct should not be correlated with each other. Okay, the correlation must not be too high, because too high correlation means if one is going up, another variable is also going up. Suppose I'm saying that I'm happy, it means I will also say that I'm satisfied. Okay, and in each case I will say that. So if I am going to measure satisfaction and measuring it with the help of just two variables, then why at all is the need to take I'm happy and I'm satisfied, if my work can happen with I'm happy also? Because I know that if I'm saying I'm happy, I'm going to be satisfied also. Then take one variable, and in order to further explain the R square, in order to predict a better model, to have good predictors, we must take some other variables also and give them chance. Why at all to give chance to siblings who are absolutely correlated to each other? So because our model becomes redundant then, and if they are too high correlated, then they will capture, when we calculate our R square, then at that time it will, our model will predict a too high R square value, too high, which is maybe 80%. And we will see that besides these two variables, none other variable is coming out to be significant. We will see that. So that is not a valid result, because multicollinearity was there, that one was moving in some direction, the other was also moving in the same direction. So we must not use such kind of variables, because it will give us spurious results which are not at all a depiction or a replica of the real world. So that's why multicollinearity has to be tested in each case before you are going to use the variables. And in case if you suspect some kind of collinearity between variables, you must drop them, one of them, and must proceed with a fewer variables. There is no sin in taking fewer variables, but there is sin in taking variables which are correlated with each other. Okay, so sin in the sense that it will give us false results. And why at all to go for false? So it says that if two items measure exactly the same thing, that can be a problem. Suppose you are asking someone that I'm happy with the service and I'm pleased with the service. So these are practically identical questions, and it will lead you to high multicollinearity. It will give you a high R square. Okay, so we check for VIF, that is variance inflation factor. Okay, so that has to be checked. That is an output in SPSS also, in your, I think, MOs also it must give. And in PLS also, smart PLS, it gives the same kind of results. So from there you can see that VIF has to be below 5, then only we can say that okay, our variables do not have high multicollinearity. And in case if we found it beyond this, then we must drop at least some of the variables. Now it further says that why is multicollinearity a problem? Because SEM tries to understand how much each item contributes to the construct and how much each construct contributes to the model. This is our main motive of why at all we run our SEM. Okay, but if you will find that your variables are too highly correlated, then the model will not run successfully. The estimates will become unstable. You remove some variable, it will show you too much variation. Okay, too much variation. If you make changes to some of the values in the model, it will give you and result out of the work. Okay, so that's why it is suggested to remove highly correlated variables. Further, it says that error terms then will become large. Okay, if we are using correlated variable, then our error terms, that is the u component, that is the unsystematic part of the model, will become too large. Okay, and our whole model is based on the error terms. That is the unpredicted form of the model which we have to predict. So error terms should not be too large, because if the model will go wrong then. Okay, so that is why this matters, to detect collinearity before entering into the SEM world. Okay, so once all these things are done systematically, these 5 tests or these 5 checks have been performed, we are ready for the SEM world, and we are ready for our SEM model, the path analysis. And that is why it is important to get these 5 tests done before performing any structural modeling, because without it, it will turn spurious. So that is about it. Further, it has been explained, there's something called common method bias that can arise in a model. Okay, since but we are having less time, and the PN is asking me to leave the place because it is already too late and he has to close the doors. So I think I was able to add something to your knowledge, if not everything. And I hope you understood something at least out of my sessions. So thank you for sparing time. In case if you have any questions, you can ask me.
Thank you,
I'm going
ma'am.
to stop sharing my
Yeah,
screen.
thank you, ma'am. We will just take one of your question very quickly, but thank you for such a simply and very, explaining in a very easy manner. So that was the biggest learning for all of the participant, because as this word itself is very traumatizing, but you have explained it in a very simple and very easy manner. So we will just take any question which is there, and then we will formally close the session.
Okay, ma'am. Just one thing I like to add is that I also have with me my PPT, in which if people want to learn the advanced part of it, that is how to perform it actually. So I have readily available PPT with me, and I will be sharing it with the our respected Fidos sir. And in case if it has to be circulated, people want it, then I'm happy to share it with you all. And in case some other help is needed, I am also always available, of course.
Okay, ma'am. Thank you so much.
Yes.
Any question which is there, you can ask. Otherwise, we will thank the resource person. No question?
Hello,
Yeah.
ma'am.
Yes.
Ma'am, you told me that, Miss, as per my knowledge or according to your session, when we are using the PLSM, there is no need of normality. But when we are using the MOS or SAM, the data should be normal. Am I right?
Yes. 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 Yes.
So it means even if my data is normal, I can go with PLSM.
Of course you can go with it. Of course you can go.
Miss, if someone asks me why are you using PLSM instead of SAM, so what reply I can give?
Since your data is normal, see this another option for not so normal data is we opt for this PLS. Okay, that our data is not normal. But if your data is normal, you can always opt for it. That is open to both normal data and not so normal data. Okay, that does not have any restriction. So I think nobody can question you on that. Further, in addition to that, you can tell them the advantages that PLS offers over OLS. Okay, ordinary least square method. So that can be your possible answer to them. Okay, but in my view, it can be used. And I have seen several research papers doing this, so I don't think there is any issue into it.
Okay, man. Thank you, man.
Yes.
Thank you, ma'am.
Madam, yeah,
We have one more
madam,
question. Yeah.
yeah, thank you. Madam, one question. What must be the minimum sample to go for SEM?
Okay, what
Sample size.
must be the minimum
Sample
sample?
size.
Okay, so it depends, what kind of research you are going to conduct. Say, for example, you are focused on what?
Further
Hello?
research, please tell further research.
Yeah. Uh, if you are if you are doing some demography study, madam,
Demographic study on what?
uh, some issues and challenges of some particular industry.
Okay. Then you
Uh,
want to use.
some modeling then.
Okay. So
Uh,
you want to analyze the means demographic features in SAM model. Okay. So
yes,
maybe
ma'am.
I think what I would suggest you is to go for 200 plus. I would suggest you to go after cleaning the data.
Okay. Okay.
Yes. Yes.
Thank you.
Yes.
Ma'am, I think for a sample size for PLSM, the KMO value should be greater than 0.85.
That
Actually,
is
I
another screening. Yes, you're right. That is another screening.
okay, ma'am. Thank you.
Ma'am,
Yes.
one question I have.
Yes.
Matlab, during your discussion, your explanation, you told that the data is required to be on the ordinal scale. Then how come we can use demographic data, which is generally a categorical data in case of SAM?
See, categorical data, like for example, which variable you are collecting.
No, ma'am. My question is related to the previous person's question. In that,
Okay.
you just told that if demographic variables are there, so it is creating a little confusion on my part. Whether for the same the data is required to be on an ordinal scale, or we can also apply same in case of categorical data.
No, this categorical data can be used in SAM. Categorical data can be used in SAM. There is no issue into that. I have you, try to even create it, or you are just asking a random question? Because
No,
it
ma'am,
can
I
be
just
easily
have
done.
only a conceptual idea of SAM. In
Okay.
yesterday class also it was being discussed because item and construct what picture I'm getting is for sure the item is going to be on the ordinal scale.
No,
So
see,
how?
suppose if some dummy variable is there for males and females, you can code it like 0 1, and you can use it. It is as good as that quantitative data. You can very easily use it.
Okay, so maybe ma'am that type of relationship will be like studying the effect of moderating variable. Is that so?
Yeah.
Okay, 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 okay. I got my answer, ma'am. Thank you so much.
Okay. Okay. So I hope we are done with it now.
I request Priyanka ma'am, if you are able to on camera, please on your camera, and rest of the participants also.
Uh, yes, sir. I have put my camera on.
Yes. So in case you are having more questions, as I have guided you yesterday, you can reach our resource person on LinkedIn or
Yeah, on
personal message.
LinkedIn too, and you can also provide me them my mail ID, sir. I'm always available, and no issue into that.
So dear participants, I am going to take photograph. So please be ready. If you are able to, on your camera, please on so that we can take few photographs. And I am having one request to all of you. Do subscribe our YouTube channel as we have uploaded yesterday videos there. So,
On behalf of JK Economic Association, a big thank you to Priyanka Yadav ma'am for such an enlightening and brainstorming session. And thank you, sir, for aligning all the participants together. Thank you for such a great initiative. Thank you, sir.